like to hand the microphone to our President and CEO, Rahul Patel, to kick things off, and then we will go right into the panel discussion that we have planned for you today. We have some really cool industry luminaries who are going to tell you about what we have in store and why Edge AI is the new frontier. So thank you for being here. Rahul?
Thank you, Neeta. Good morning, everybody. Good morning. It's a beautiful day today at Synaptics. Thank you for taking the time to be with us. Truly, it's a moment of pride for all of us at Synaptics. What we have unveiled today is a product of superior engineering and R&D of our teams basically at Synaptics. I'm really proud to say and share with you the silicon on display, the one that we announced, the SL2610 family of products, has been barely 4 weeks with us, and you can see how good it is. This is our first silicon, and the capability that you are seeing is all real. It is something that we did not anticipate to be this good, but we were very confident. And so I really want to thank, first and foremost, all of my teammates, especially our R&D team, for putting together and bringing to life this phenomenal product. A big round of applause for Synaptics R&D team. Woo! Secondly, I also want to thank Neeta and the marketing team and everybody who's put together this phenomenal show of Synaptics' capabilities today. Big round of applause for the marketing team. And last but not least, I want to also thank all of you for taking the time to be with us. Believe me, we had such a huge, invite list that wanted to self-invite. However, there was not enough space for us to kind of bring it all in-house. And so, believe me, again, you all are very special to us, which is why you made it to this event. Thank you for coming. To all our friends in media and analysts communities, to our customers, and also our shareholders are here as well. So big round of applause for all of you for taking the time to be with us today. With no further ado, I will at this time turn the microphone to our panel moderator, Nitin Dahad of EE Times. Thank you, Nitin, and welcome everybody again.
Hello. Yes, good morning. Thank you, Rahul. And welcome to this panel, which I've been asked to moderate. Thank you very much. And I'm going to ask my panelists to come on stage. And I'm not sure which order, but let's go with Vikram Gupta first. Synaptics, Billy Rutledge, David Steele, Pete Warden, and Yick. Have we got everybody? Great.
I'm number 3.
Well, I'm going to take a seat. And good morning, everybody. Thanks for joining the panel. Our panel today is Silicon, Software, and Scale, Making AI Work at the Edge. Now, I see there's a lot of people who are more experienced than me in this, but I'm going to take an attempt at running this. My name is Nitin Dahad with EE Times magazine. I'm going to ask each of the panelists to introduce themselves and maybe just a couple of minutes just to talk about what they're doing and AI at the Edge. I've seen some of the demos already. Very impressive, especially some of the robotics ones. So let me start right from the end. David.
Sure. My name is David Steele. I'm the Director of Innovation at Arcturus. We're an Edge AI company. We specialize primarily in vision AI for industrial applications. So that's kind of the perspective I'm going to be trying to share and promote within this discussion as well. So there you go. I think,
Billy Rutledge.
Yeah, hi everyone. I'm Billy Rutledge. I head up the Systems Research Group within Google Research. And we're here today to talk with you about an announcement that we've made this morning, the Coral NPU that we've open sourced, which is being integrated into the Synaptics Astra line of SoCs.
Thank you. Vikram Gupta.
Yeah, morning everybody. Vikram Gupta. I'm the Chief Product Officer at Synaptics, as well as I'm responsible for the IoT processor division. So I've been in the industry for 30 years, focused on processors, connectivity, and IoT. I came to Synaptics about 2.5 years back. Synaptics is very focused on the core IoT as a market. And however, we are emphasizing the edge a lot. We are very bullish about the edge. We believe a lot in the edge. And last year, we announced the Astra line of SoCs, which are AI native. And today, we're really happy, as Rahul mentioned and Nita mentioned, happy to announce the SL2610, which is the next in line of the Astra series. And looking forward for it to light up a number of different applications in industrial and consumer segments. So happy to be here, looking forward to this discussion.
Vikram, thank you. Pete Warden.
Awesome.
Used to be Useful Sensors, now Moonshine AI.
Exactly. So we do voice interface software and models designed to run on the far edge, to be really small, really resource constrained, but still super accurate. You can see a couple of our demos around. And this feels kind of a bit of a reunion because I used to work at Google very closely with Steele and Kai. So maybe that's a good segue.
Kai Yick.
My name is Kai. I work in the platform ecosystem part of Google. We work on emerging wearable device that's hopefully going to come out soon. I'm very excited about it. Energy efficiency and enabling AI capabilities is very important for what we work on. And leveraging what Synaptics and the Google research team is doing is something that we're really looking forward to. Like a lot of these emerging capabilities where we could bring capabilities, AI capabilities to the edge where we could be transformative is what we're after.
It's funny you say energy efficiency. I was just at OCP this week, and you've got energy efficiency at that scale. You've got energy efficiency at the edge as well.
Different level.
So I'm going to ask a few questions, but then I would suggest if anybody has any questions from the audience, maybe raise your hand. But I'll start with the ball rolling. I've been writing about Edge AI for a long time. We all have been hearing about it for a long time. Why do you think we're at an inflection point? And I think, I know the answer, but I want to sort of encourage a bit of a debate. And what's driving the optimism now? And what's needed to make an application ready for AI at the edge? I don't know if maybe Vikram can lead with that a little bit.
Yeah, I think, there's a lot of talk about the cloud and a lot of investment going in the cloud. The cloud is still getting built out. But I think there's definitely a realization that having intelligent outcomes at the edge is going to be more beneficial. So we all know the benefits of doing things at the edge. Your response time is a lot better. Energy consumption is a lot lesser. As well as some people think about privacy.
1 second, just need to adjust your microphone.
Okay, thanks.
Start over.
When I do video interviews, I do ask people to project their voice. Please project your voice.
Okay, so I was saying that the edge has these benefits. The fact that you can, you care about privacy, the response time is better in terms of the outcomes, as well as you consume less energy. So I think we are at a point where people are realizing that there's going to be, there's enough happening in the cloud, but the edge needs to now complement the cloud in a way where you're going to see a wave, at least I believe, a wave of hybridization of applications that used to run in the cloud happening between the edge and the cloud. So that's one thing. And I also think that there are going to be solutions that come out from all of us. Not working? Okay. All right. Solutions.
That edge device is not working.
That edge device is not working.
There we go.
Well, it's connected.
It's clearly not Synaptics part.
So I think the newer devices are coming out and newer capabilities, which I think will also start inflecting the edge as newer applications come to the fore. I'm really bullish about not only basic applications becoming more intelligent, but also wearables starting to come and really have an influence in our lives that will really make this edge thing have its own Gen AI moment. That's my perspective.
Billy's nodding, and when I interviewed you in January, I think you talked about the wearables.
Yeah.
Why don't we just go there?
Yeah, just to build on what Vikram was saying, I think we've all witnessed and felt the power and the capability that the large cloud-based models can provide to us. And I think the next big leap that we're looking at is how do we bring some of that intelligence down to smaller devices so that it can be with us on the devices that we use and interact with every day in the different places that we are. And so we've been looking at what are the gaps that it takes to make that happen. You mentioned power and performance. Obviously, that's one of the key challenges that we're looking into. But also things like the developer fragmentation tax. We think about how hard it is for developers to build across the multitude of different ASICs and SoCs that are out there. How can we help simplify that? And then also, obviously, security. As devices are around us and on us, looking at highly sensitive user data, how do we have the right level of security guarantees to make sure that they can trust the devices that are actually on the edge?
We're going to come to fragmentation in a little while, but let's talk to some, David, I think you've got some applications which you're...
We're talking about inflection. Wait, I'm trying not to get feedback here. So we're talking about inflection. So I think that from, if we think about industrial, I think that a lot of industrial customers get very excited about inspection applications and vision applications, and there's been a number of limitations that have really prevented them from realizing the full capability of it. Partially because some of it's run through cloud processing. Then we have data sovereignty, we have privacy issues that just don't make it applicable for industrial customers. So when we start talking about the edge, here's where they get really excited, because now we can do it real time, low latency, but we eliminate the data privacy, the sovereignty issues, and this really lets them capture it. And so the inflection points from the perspective of that, using traditional models, and now moving forward, we're seeing the scale down from big cloud models with transformers to vision transformer models at the edge as well. I think those things are all sort of converging.
Pete, I know you have quite a good perspective on this in terms of how it's where are we on the inflection point?
So as far as I'm concerned, people are paying us money for
that's a good sign
for edge solutions. I've honestly kind of given up on the media and investors, apart from our lovely investors, of course. But there's been this real reluctance to get excited about edge AI solutions. I've seen over the last couple of years, especially, if you look on Reddit groups like Local Llama, there are people who are building something that's very close to ChatGPT or Claude running locally on their own machines. Now we're actually seeing customers who don't care about AI, but care about saving money on the warranties they sell. So getting local voice assistants. All these people who are not driven by the AI hype cycle are realizing that there are ways to help them save money and make money using these things. And honestly, I think we just go ahead, keep grabbing that money while nobody else is paying attention and everybody's focused on spending $100 billion on data centers for something that you can do with a $1,000 laptop. And focus on making money. That's my inflection point.
Well, that sounds very much like British pragmatism. Kai, do you have any sort of thoughts on this?
I have some thoughts, but let me know if I derail myself.
Okay.
I have some thoughts, and hopefully I don't derail myself. You're welcome to stop me. So one of the things that's coming out now with essentially these large language models on data center is this intent to, I'm going to send everything to the data center. But it's not an ideal situation where if you have a wearable device, you want to transmit to the data center and do the round trip every single time. So the question is, what can you cascade down? What can you do on the device, especially something with such a small battery, right? That energy efficiency is very important for us to achieve. But with these new capabilities and this evolution of models, then it becomes, how can we enable the AI acceleration to be done in a way that's efficient, right? So we could actually enable certain capabilities.
Yeah, I mean, I'm just wondering, because my media friends here and analyst friends have been writing about this for a long time. Are you all suggesting that maybe it's not as prevalent in application and deployment as we write about?
I think it is in the, when Pete, feel free to correct me if I'm wrong. I mean, in the traditional sense, we want more the CNN traditional model, hot dog, not hot dog, and stuff like that. We're trying to advance one step further from that. Okay. How can these models work together in cascade, in conjunction with one another? How do we build ambient context? And a lot of these capabilities require evolution of the model architecture from the big form in the data center to the smaller form on the edge. But then hardware doesn't always catch up to software or to model architecture, right? So the question is, how do we accelerate it, and how do we shorten that development cycle to make that possible?
Vikram.
Yeah, I just want to. So I just want to add to something what Kai said. I think the kinds of applications that Kai is talking about are sort of like these ambient, sensing, but really powerful AI-specific applications that are going to change outcomes for us as consumers. And those definitely will have their own place. But to your point about, hey, are you seeing any further applications out there? Yes, there are applications that are happening, but a lot of these are sort of like things like personalization of things, or in some cases, it's not even as visible as that. It's like the device knowing what it's doing, and it's aware of its state, if you will, and the environment it is in. And it does something which is sort of its regular operation, but does it better. So there's a lot of those kinds of applications which are also happening at the edge, and you don't see them. But my point about the wearables was that it's an aha moment. Okay. When we start wearing it, then we're going to, just when we all got exposed to Gen AI, ChatGPT, it suddenly hit home for all of us. And then people started talking about it. So that was my point about the wearable thing really inflecting it.
So it's like my watch telling me, oh, your heart beats high, do you want to do something else? Something like that?
Even better than that.
Billy, I think you were sort of wanting to say something? Oh, no.
I'm just following along. I think Kai hit on one of the key points that we like to talk about.
Just get the mic. Yeah.
And that's ambient context. And so having devices that can actually capture more about you and what you're doing, what environment that you're in, and do so efficiently, and being able to share that back to a network of other AI models to create a combined, more complex experience than we have today is something that we really want to shoot for. And I think we're really at the point now where we can start pioneering some of those experiences, because we have architectures like the SL2610 that let us run that class of model for the first time efficiently on edge devices.
Yeah, highly smart sensors.
David.
I was just going to add the comment. I mean, from the industrial perspective, again, we're looking at the opportunity of developing highly smart sensors. I mean, that's really what we're looking at. A dual core with a powerful NPU that can handle transformers is great for industrial applications, where we really want to bring a whole different level of intelligence to whatever we're processing. For sure, absolutely.
I'm going to move to a little bit more of the practical side. Running transformer models efficiently on constrained silicon is no small feat. How do you see the need to balance specialized acceleration with architectural flexibility, and so that hardware can evolve as AI models rapidly change? And that really is key, isn't it? So I don't know, does Billy want to talk about that, or?
Yeah, I think what we can touch on is the architecture of the Coral NPU that we've released today, that we're bringing into the 2610, and how it provides a flexible design that companies like Synaptics can take the base design that's open source, be able to extend it, specialize it for different industry segments, different models that they would want to run, but also that it's standards-based, so that we have a very developer-friendly common front end, where models can, when you deploy them, just actually work, but then you have the ability to specialize them, optimize them through these standards-based programming environments that we make available.
Vikram, yes.
Yeah, so the way we think about it is that, firstly, let's acknowledge that the cloud actually is innovating rapidly, meaning there's still a lot of stuff happening there. When you think about what needs to go into the edge, you worry about how you want to future-proof things, because you put acceleration, let's say, into your product. Your product comes out 2 years later, and by then things have evolved.
Exactly.
So when we took this approach of being AI native, we made a very fundamental choice in the beginning that we wanted to be in control of the AI sauce that went into our SoCs, so that we could differentiate and bring a better experience to our customers. and therefore enable AI products faster. So we decided to kind of invest in our own NPU acceleration, and then we got together with Google, and we found that we were thinking about things very similarly, both on the hardware side, on the Coral, using Coral as a base and our hardware engine, but also in the way we looked at the software. And we decided on open frameworks with their help, and we're also very big on open sourcing what we are doing, unlike everybody else who thinks about walled gardens and so forth. By doing this, we think we're going to be future ready, as well as what we believe is coalescing the ecosystem around the edge in a way that builds on itself.
Okay.
And therefore prevents the fragmentation that you're talking about.
Okay.
That's our vision.
Pete, you've been doing this for a while. What do you think about that balance?
Well, my big ask, and I've talked to Billy and Kai about this, is just have general purpose compute in the accelerator and accessible, because we saw so many hardware accelerators just get obsoleted overnight when we moved from CNNs to transformers. But even there were much smaller changes, like researchers are constantly coming up with new activation functions that provide like 0.1% better accuracy. But what that means for all of us downstream model developers, software developers, and hardware developers is if we can't just put that new activation function and actually support it in hardware that was designed like 2 or 3 years ago, then we're just not able to run those models, because we can't go back to the model creators and say, oh, can you actually use a different activation function?
Yeah.
And so even though it's a tiny amount of processing and calculations that are in an activation function, if you have to go back to the CPU and then back to the accelerator to do it, then you often lose all the benefit of the acceleration. So the drum I've always been beating as a software and model person is just, please have an escape hatch, so even if it doesn't run fast,
It runs.
it runs.
I got to echo some of Pete's
David.
points as well. One of the things that we find doing classic CNNs is pre-processing. I mean, pre-processing functions falling back on the CPU. And one of the things we found that was fairly unique about what Synaptics did with their toolkit was actually add the model pre-processing function and capability into the NPU. So now we actually have a much more efficient way of maximizing what we're doing with specialized compute, giving us back CPU cycles, which we can then use for other things. And that increases the compelling value of that whole chipset, because quite often we find that the pre-processing functions can be as time-consuming as the whole forward pass of the model. So I would completely agree and give a totally different use case example than Pete, but completely concur on that.
Yeah, I just want to add something to what Pete said. So we look at it as an 80-20 problem. So the new activation functions that show up, you have to have a path for addressing it, but the majority of them have to be run efficiently, and so that's why the Coral NPU, along with the Torque hardware that we have, works really well together. We have a default path that is efficient, but if new things come up, we have the other path, and that's how we address it.
Sorry, you want Kai?
Yeah.
Go on.
I think the fact that you could just compile the thing and have it work is freaking amazing. I think Pete touched on all of the pain points that I have as well. I think the only thing I want to add is the fact that the toolchain is open source. And it makes integration into our development system so much easier. And we're happy to contribute a lot of patches and fixes and changes back to actually make the toolchain better. So having the ability to fix issues, evolve the design is huge.
I'm going to open up to the audience if anybody wants to ask a question. Otherwise, and Bill Wong, player. Do we have a mic to? Yeah.
That's all right. I can just project.
Let's use a mic. Yeah.
Oh, we got one.
Thank you. My question is sort of a follow-on when you were talking about.
Bill, just hold it closer. Yeah.
Okay.
Yeah.
There's a follow-on, essentially talking about how you're progressing with the models over time. What's the half-life of these platforms? And while it makes it less of an issue in commercial assembly line where you may have static things, in commercial and consumer, we're potentially turning these things over very quickly. So, how long are these going to be able to last, especially since, NVIDIA keeps churning out essentially doubling or quadrupling performance every year?
I don't know if David, you showed me a demo this morning, which kind of addresses part of that, but then we'll move on as well.
Yeah, maybe I've got a couple of quick thoughts. So one thing about model adaptation. I mean, this is an interesting.
David, just hold it closer.
Sorry, one thing about model adaptation. This is an interesting sort of concept. I mean, and model training and the amount of data that you need, and that's growing. I'll give you a use case example. So we have an industrial customer that's way in the north. They run a series of log mills, and their data, because they're ingressing logs from ponds, those ponds look very much different when it's minus 30, and I'm using Celsius here because I'm Canadian, minus 30 than it does when it's plus 30. And so for them to collect data to create a perfectly generalized model from a hyperbolic standpoint, it's going to take a year for them to do that. For them to be able to have the tooling to adapt that model over time, get data from the field, regenerate models, deploy models, it's critical for them to be able to deploy anything in production early on. So I think that's kind of a key sort of thought about the practical applications or the practical considerations that can address drift and other things like that. So that's kind of just what I wanted to throw in there. My hat in the ring about, that's that concept.
Pete.
I'll use this. One key thing, even though NVIDIA is quadrupling performance like every year, the actual value added by LLMs has really plateaued. Now, maybe there's going to be another breakthrough in like 6 months, which suddenly accelerates things. But, what we're seeing is that, the new versions of Claude and ChatGPT are refinements, not kind of revolutionary leaps. And what that means is it's a chance for the hardware and the software and the deployment to actually catch up with this breakneck kind of speed of things. And the current hardware, even that's coming out now, like the Synaptics stuff, is fully capable of running very good LLMs and all of the things that come with it. And I think that there's going to be, even in the consumer side, there's going to be like years of use that you can get out of platforms that are coming out today, because I'm not expecting a massive change in LLMs. I may be wrong. Something may come out of the woodwork. But if we continue as we are now, then we're going to have hardware that's capable of running really good LLMs that's coming out today, the Synaptics stuff that we've got here, and it's going to provide a lot of value to consumers kind of for years to come. So that's my thinking.
Vikram.
So I'll just echo that. I mean, I think I wanted to your question, Bill, specifically, the half-life is, I'm not worried about it. I think the hardware that the line of products that we announced today has this capability, this transformer capability that will have a fairly significant runway for us, both on the consumer side and industrial side. Having said that, as we pointed out earlier, it's we have this 20% pathway of this escape hatch, as we had alluded to. So we can always compile and run anything like Kai says. That's not an issue. So we are future-proof in that context. The other thing that I'll say is that our relationship in terms of how we are collaborating on this, on Torque and Coral, is a multi-generational one. And so as the cloud keeps evolving with, let's just say, whatever is happening on the Google side, they're going to, that research is going to percolate down to the edge. And we're going to be collaborating as to what should be the next version of the Coral NPU and what is the Synaptics Torque NPU going to look like as an adjunct to it to kind of keep the ball moving forward. So that's how we look at the whole thing.
Billy.
I think it's a really good point. When we started the work on the Coral NPU a few years back, it was really based on a lot of feedback from our first generation Coral work that used the Edge TPU ASIC. But the models that we were designing for then and with the Coral NPU were CNNs, things that would allow us to do human level audio and image sensing on device. Since we started that work, we've seen the trajectory of large language models, and we've been able to adapt the architecture since we've started to accommodate model changes that we see inside of Google Research. So as we bring new model architectures forward, we're co-designing our NPU design to match that. But I think the key point that you've both hit on is that it's flexible and it's easily programmable. So as new activation functions and new components do come forward, we can easily update that through software and feel confident that it will work while we find the right way to optimize it, and then bring new milestones of the NPU out to go into the longer roadmap with the Astra Silicon.
Hi, Amy Kalnoskis with EE World. So as long as we're talking about hardware and software in the same sentence, let's take it up a level and talk about the people. How closely do you feel silicon designers and software engineers need to work together, historically not the best relationship, to make Edge AI successful? And what does that look like in real life, in practice?
It's actually a good question, Amy, because we were talking about the silos in our pre-briefing call.
Yeah.
So maybe you want us to take that first, Pete.
Yeah, and one of my favorite experiences was when I was at Google working with, Billy and Kai. Yeah. One of my favorite experiences was working at Google with Billy and Kai and the rest of the Google Brain and research team and the deployment team, because we would literally have hardware experts, software experts, model architects on the ML side, all sitting in the same room. And you may be familiar with MobileNet, which is one of the classic models. That came out of a group within Google where the people writing the inner loops on the software were constantly in the same room talking to Andrew Howard, who was designing the architecture, and they were talking to the people on the silicon side to understand what would be best for the silicon. And that level of co-design is just fantastic. And the closest I've come to that outside of Google has actually been working with the Synaptics team.
Right on cue.
Yes. And honestly, I was just having a conversation with Abdul about how we can modify our pre-processing in our Moonshine model so that the strides will be fit better with the actual, the silicon that they have now, so we can get some tangible benefits, so that we're not just recipients, they're not just recipients of a model somebody else has trained that they can't change. They can give us hints on what they want to, how they can run stuff efficiently. We can give them feedback on what we need for future models that they can then put into the silicon. And I know this sounds like a paid ad, it really isn't, but it's been so great working with the, Synaptics driver and hardware teams, and it's a big reason why we've been able to do what we've been able to do on Synaptics hardware. So I think you're exactly right.
Billy, and then
just a quick
David.
comment. I just echo what Pete's saying. I think co-design is the important thing, and being able to have that really nice virtuous cycle where the hardware designers are working closely with the model developers. And I think that's one of the unique things that we have, and why bringing this architecture forward as open source is really valuable. I strongly feel a lot of the model architectures that have become stable and widely used today have come from within our organization. I think more will come. And to be able to adapt our open NPU design to fit with that and ensure compatibility and performance is really important. And so we follow this principle every day with the work that we do.
David.
Sure, I'll just jump in and maybe I'll throw ARM a little shout out here. So I think for us, we use a containerized environment at the edge. That would not be possible if it wasn't for ARM v8. That gave us the software compatibility to be able to run containers at the edge. I mean, I think that's a really simple example of how software and hardware can work together. I mean, I'm taking it to the core level, not so much the AI level, but from a functionality and from a capability standpoint, that's absolutely transformative in the way that we can roll out edge and manage edge software and stacks. Absolutely transformative. So.
Vikram, do you want to say anything about the praise you've been getting?
No, I think I just want to keep quiet actually because they said it really well.
Yeah.
The only thing I'll say, one level removed from them, I think it's fundamental that you have to have core design when you're talking about SOCs and the kinds of products that we do. So it's in the nature of everything that we do. But having said that, when we talk about AI native, that just means that we are thinking about how best to make the AI sauce that much better between hardware and software, and also keeping the customer journey in mind. So all of that comes together in a way that it has to blend. It can't be one side thinking and the other side not. So
one of the things I think Pete raised previously was on an extension to that question is, are we getting like the departments or silos between AI and ML engineers and product developers and not working together? Or what was your point when you were making that, when we were talking about it before?
Yeah, I think there are actually three groups here. There's the people who create the models, and at the moment, they're essentially like little princes or princesses who are kind of, up there, who kind of like pass down a model to,
I've heard this.
Yes. And so just because model architects are so in demand, people who can create models and train models, they really don't have to be responsive to, even the people who are deploying them on non-NVIDIA hardware. So the ML engineers, and then there's even often a kind of a status kind of gap between them and the product people. So if the product people, often they're in at least different orgs, maybe even different companies. And I see that as stifling so much development right now. Like, I loved when Quen, DeepSeek put out their model that suddenly was able to do really well on the benchmarks and offered a great solution because they had really thought through the end-to-end. A lot of the current model creators, they're almost incentivized to make something that's like hundreds of billions of parameters because it's kind of like bragging rights.
Yeah.
And so I think the only way we're going to move forward is by setting out social structures within these companies and between companies that actually let the feedback from the people actually putting these things in front of users and let that feedback actually affect what's happening kind of upstream from that, which we're really not seeing right now, except with Synaptics.
Anybody say anything on that? Otherwise, we'll move on. No? Okay. Any more questions? Otherwise, do we have any? No. One of the things I was going to ask you around is, there's a topic about fragmentation we talked about earlier. I think I first wrote about IoT back in 2015 or 2016 as IoT. I mean, it's been around for a long time. And one of the things we saw over the years is we didn't get the billions and billions of devices connected because of the fragmentation, lack of interoperability, various other things. But now Edge AI is kind of that new IoT, and there's a huge diversity of applications. How are we going to get over that fragmentation? And I think, Billy, you've probably got a little bit of a response on that open approach, but maybe we can just have a little discussion about fragmentation.
Yeah, thank you. The point there is that for us to battle the fragmentation tax, we really need to center around open standards. And so with our work, we've put our designs together using the RISC-V ISA. And so instead of creating a new open standard, we're joining forces with what we think is the right emerging standard for this space. And by offering a standards-based open source solution with a developer-friendly open set of tools to be able to program it, we think we can maybe down-level the fragmentation by encouraging adoption of this as a base design, so it becomes a common format for everyone to build upon.
Any Vikram? Oh, sorry, Pete. Yeah, all right, Vikram, go on.
Okay. Yeah, I mean, I don't want to jump on another hobby horse.
Feel free. This is a platform.
Consumer IoT has been an absolute failure, and I believe it's because it really hasn't offered benefits to consumers. It's been designed around trying to help companies' business models by getting subscribers, but without ever stopping to think, like, okay, why would a consumer want this? And, you know, for example, I talked a few years ago to a team that was building an internet-connected dishwasher. And, you know, they'd spent 6 months on this project, and they between them, they had not been able to come up with a single reason why you would want to have, you know, what consumer benefit a connected dishwasher would offer. But with the edge IoT stuff, what I really like is, you know, we've got demos over there where you can press a button, ask the dishwasher, hey, why are my dishes still wet? And completely locally on a really, you know, low single-digit chip, low single-digit dollar chip, you can actually get useful answers. And it doesn't get you a subscription. It doesn't, you know, sort of, you know, build into some like attractive business model for Wall Street, but it's starting with something that actually helps people out and also saves companies money because they no longer have to do as many truck rolls and they don't need as many call centers. So that's my rant about IoT.
So actually what you're saying is Edge AI is not the same as IoT in that, you know, it'll become more useful than IoT was.
We're starting with what consumers need.
Yeah.
And then kind of like working backwards from there versus starting from what companies need for their revenue model and then trying to kind of shoehorn a horrible consumer experience and hope that somebody actually uses it.
Yeah, Vikram. Sorry, go ahead.
I was just going to build on that, Pete. I mean, that's your demo with the dishwasher with your AI models. I'm not sure which SoC it's running on, but you know, you as a model builder and a business owner and founder, if you wanted to take that model and deploy it on 15 other different SoCs, the burden of managing those tool chains and those dependencies and those sources and being able to keep that current and deployed, I mean, you could probably speak to what a difficult challenge that would be and how it actually set you back as a small business. So having the open standards and common front end so that you can easily port your model to other devices and other architectures is really a game changer. And to your earlier point, Nitin, we want to try to address this early on as this Edge AI cycle is coming forward. Have it from the beginning so we're not trying to retrofit things 2 years from now.
Vikram, please.
Yeah, no, I was just going to say that I disagree that the IoT isn't a thing. It is a thing, and all you need to do is, you know, just look, you know, in your own homes, look at the number of devices you have, right?
I think it was a bit of a generalization.
Versus, you know, 8-10 years back, it was a significant number. So there's a whole bunch of devices. The way I think about Edge AI is it's going to be a layer on top of all of this that's going to simplify this perception that IoT doesn't hunt or whatever, right? So that, I think Edge AI is going to make it easier for us as humans to interact with these devices and have meaningful outcomes. So that's my take on it.
I mean, this is unrelated to here, but I think one of the things on that is the reason why Matto was set up is because, you know, to put all of this together for the IoT. But it was going in lots of different directions. Yeah. And I think that was the point. Yeah. Any other question? Please say who you are. Sorry.
Hi, Mark Hockman, PC World. do you see pervasive connectivity as a headwind or a tailwind for Edge AI? Because in your example, you're using, I can ask the dishwasher why my dishes aren't clean. As a consumer, I guess I would prefer to ask a more sophisticated cloud model and get a better answer in response. So my question is that when we're talking about edge devices and Edge AI, is it a good thing or a bad thing that there is pervasive connectivity and connectivity to the cloud?
And maybe I can. So to start off on that, and I hate to beat up on like IoT even more, but if you look around your home, manufacturers, the optimistic estimate is that 50% of smart appliances are ever connected to the internet. Talking to manufacturers, we see less than 30% as much more realistic. So the technological possibility of having pervasive connectivity meets the reality that to get that connectivity, you have to download an app, you have to create an account with a special account, you have to type in your Wi-Fi password over a Bluetooth connection, you have to pray that the kind of, you've got like 2.4 versus 5 gigahertz, or you've got a cell connection that works much better, but then only lasts for 2 years because somebody's having to pay a subscription for it. What we've seen is that it's that 80-20 thing again. Like most questions can be that you're asking about a dishwasher, you can find in the user manual. It's just that we've lost the user manual. And so you can get a good answer to most of your questions by using a local model, and you can run pretty sophisticated LLMs, especially if they're specialized for a particular field. Like asking Claude about dishwashers is using kind of like a 0.1% of its capacity that knows about like appliances, whereas training an LLM that's a few billion parameters that it lives and breathes dishwashers, you're actually likely to get a much better answer out of that, and you can run it locally. So anyway, I'm ranting.
So, Pete, you've sort of described my total user experience with my LG connected fridge. Connect to the Wi-Fi, connect to its network. It doesn't work. I want to order a part. It doesn't work. So I don't use it. But sorry, go on.
No, I was going to say that we need to have a couple of spirits and discuss this at length.
Yes.
I got to set you right on the IoT. But look, I think that devices do need to be connected, and I can give a simple use case. You have a intelligent AI IoT hub in your home, and you're having a very natural language conversation about it. And if that hub is going to connect to these other devices, your LG refrigerator, and do something meaningful, it needs a connection. So connectivity is pervasive. It has to be there. I think the other thing I would say is that there will be, if these devices, if you play this angle out that Edge AI is good enough to do a lot of these things, your 80-20 thing, the devices will need to evolve as they are interacting with other devices. So if you want to push more meaningful stuff down, how are you going to do it? You have to be connected. So I think those are things that one has to keep in mind. I think connectivity is the backbone of a lot of these things. I do think that Edge AI, that's why I say that I think with some of this capability that we're introducing, it's going to make it easier for us to use these IoT devices.
I think Pete's point about user manuals disappearing and the ability to put this on the edge, on the device, and then you can natural language ask.
Absolutely. I'm not saying that's absolutely useful. And, I hate fumbling with my Bosch dishwasher and trying to have it run. But if I can talk to it, I would love to do it and actually have it do the cycle that it needs to do. But it needs to be, my only point was it needs to be connected as well. It can't be without its connectivity.
And maybe I, go ahead.
Go ahead.
Just to jump on, I don't think it's either. It's both. So having an edge-capable device that can handle, a conversation about the owner's manual is fantastic, right? But let's say you hit something that it's not able to answer. Can it not cascade back to a more sophisticated model because it is connected? And it also maintains itself as you're describing. But wouldn't it be great if you could just talk to the dishwasher, have it go through the pain points, Pete, that you enumerated with choosing the right Wi-Fi, your password, and all of these things, just, from it knowing you, can you just have it set up that connection and maintain it for you and use it when it's needed?
Pete. and yeah, I totally agree. It's not either or. I love having connectivity. And one of the key use cases we've seen for the voice interface is actually getting connectivity easier, because you can talk to the dishwasher and give it your Wi-Fi password without having to download an app. But the key thing is you need something that doesn't rely on connectivity to give you some value before you can get consumers to actually engage with something. So I think we're violently agreeing in some ways. But it's So I don't hate connectivity. I love connectivity. I just don't want it to be a blocker for getting something useful. Yeah.
So, I could give a pretty simple use case. Again, coming from the industrial perspective, it's important to have a production line that can run standalone. You want to do inference with low latency. I talked about data sovereignty and data privacy. We don't want to ship that up to the cloud, but it doesn't mean that my application shouldn't be connected to my enterprise resource software. So I'm still going to need that connection. There's no question about it. It just may not be the connectivity that we think of to the cloud, right? So absolutely critical.
Any more questions? Please say who you are.
Hi, Matt Bromage. I'm with ARM. Thanks for the shout out earlier. So, as with any hardware edge device, there's always a trade-off with how much hardware you put in, how much software you put in, and talking about how we want to promote more conversations with the architects of the models and with the hardware designers. I'd love to hear your feedback and kind of how you think about giving feedback to the hardware vendors about how much NPU performance do you need from your hardware. You've got the hardware performance coming up year after year. The model complexity is increasing, but actually at the same time, the model complexity is also coming down, right? And you're finding new ways of optimizing the models, especially at the edge. How do you think about converging those two moving targets in terms of talking to each other?
You're talking about the end user, or?
I'm talking about the model architects, the AI application developers, and the hardware vendors who are thinking about the next generation of Coral or the next generation of NPUs. How much general compute are you asking hardware vendors to put on there in addition to the NPUs? That type of conversation.
It's quite a Go on.
Let me take a shot at it. I mean, I think how you define the product and how you have the flexibility, what's the right amount. It's a classic product management problem, fundamentally. One of the things that we try to do when we define our products is we try to cover a broad range of perspectives, which means segments, as well as having interacted with our customers in those segments and what they're seeing as the trends from their point of view. In some cases, they want that conversation with us about what can you help me with to add some intelligence to my product. And so it's a two-way conversation. And the consolidation of all of those interaction ends up being this matrix. And so one of the things we have done with the SL2610 is when we launch it, it's got these, it's an SoC that's been put together to address a variety of segments, industrial and consumer. And what we offer, though, is multiple flavors of it that fit what a hardware designer needs for a very specific use case that they are interested in. So someone can look at a catalog and say, I want that version of the 2610. And that's what we will get. That's what they will get with it. And that's how we try to address it. So you can't have a magic pill that addresses it. It's a conversation. And the other thing I will say is that 2610 is the first in the 2600 series. So there'll be another one that offers a little bit more capability that covers a broader range of other applications. So You can think of it as like a Venn diagram of a number of different products that cover a broad swath of areas that we would want to go address.
Yeah, with our design that's in the 2610, on purpose we tried to go as small as possible with the base reference implementation. So our target design was 512 gigaops with a certain power threshold, making it flexible and configurable so that when companies like Synaptics take the design and implement it across a family of SoCs like the SL2610, they can adjust those parameters and get the performance that they want for the different segments and the different models that they intend to run. So having a configurable base design that allows for you to specialize it, I think, is an important part of solving the question that you're asking.
Jim McGregor.
Thank you, Nitin. Gentlemen, Jim McGregor from Tirius Research. I want you to look into your crystal ball a little bit here. As we're enabling this army of intelligent devices everywhere, anytime, what do you think collective AI looks like? Is it where we're actually having to have a master that looks at all these different devices and decides who has priority? Is it them just kind of coordinating between themselves? Or is it actually being able to spread that AI workload across all these devices and being able to pull, having my refrigerator use the sensor in my thermostat to actually decide what it wants to do? What does collective AI look like?
That's kind of networking the AI, isn't it?
Yeah.
Who wants to go on that one?
So, it's a good question, and we are seeing software solutions actually that are looking at devices in a distributed sense within a certain vicinity to realize what can be done as a collective. It's sort of a fledgling thing that's evolving. I do think that's potential. I have my own concerns about it, so I still like to think of the devices in isolation. But the collective one is an interesting thought about what would it mean as a collective if intelligence needs to be up-leveled, and what does it mean in different tiers, if you will. I think if you look at how it's going to evolve, there's probably going to be different shades and different protocols on how all of that comes together. The most basic being what happens on the far edge. And what happens in the cloud is obviously the most powerful, and there's going to be all these different shades in the middle.
Anybody want to add to that?
Yeah, this may be a little bit wacky.
Go wacky.
So one of the visions I have for smart devices is the Disney home, kind of where you walk in and you can talk to everything can talk to you. So my touchstone is I want to be able to walk in a room, look at a lamp, say on, have that lamp come on. Like, that should just work. But then if you've got your lamp next to your TV, you're using gaze detection and you're kind of looking in the direction of both. How do they coordinate with each other as to which one should turn on? I actually kind of like the idea of them talking to each other using human language. So, the lamp can say, no, I got this. And have this whole kind of like social mimicry idea. It may be awesome, it may be super creepy, but it's how we all coordinate with ourselves, like on this panel. Like, we look to each other, we talk to each other, and it's also a language that everybody can understand. So, the human user can know that they're not talking about you behind your back. You're actually understanding everything that's kind of going between them. So that's my slightly, hopefully cool but maybe creepy idea of how things might be.
But that's not really far off. You've got handshaking and prioritization between devices. You can build that in with little bits of software, can't you?
You can, but like with Matter, it's like, yeah, you've got the shared standard, but like nothing is nothing works together. It's like trying to set up something that's from, connect to an Apple home something that uses Matter. It just doesn't work. I'm maybe a bit skeptical of coming up with new standards, and we've got a standard which is which is us talking to each other in human language. So
very good. If anybody wants to add to that, otherwise I'm going to conclude the panel.
Sorry.
There you go.
I feel like I'm going to say the same thing Kai is about to say.
Yeah.
So maybe I can start and you can add on. I think it really depends on the case, the user journey, maybe the industry that you're in. I don't think there is a single collective AI vision or solution out there. Lately, we have been thinking about how to make people more capable using AI. And so having the ability for the AI to get enough information to provide a useful set of preemptive, user journeys for you is really what we like to think about. But being able to have devices understand where you're at, who you're interacting with, what you're hearing, what you're seeing, what devices are around you, I think is the basis for creating that. And that's probably applicable across different industries, whether it's automotive, what your in-car experience might be, versus industrial, and how these devices work together to maintain themselves for a common person. But having them connect, I think, is probably the base.
Maybe to add to that, I think security privacy is very important in that regard. I mean, Synaptics has a great foundation to build on top of that. And we do plan to continue to collaborate with them to advance that technology in the future. But and I'll tell you my perspective, because I'm more focused on kind of like the wearable type of device. We are looking at cascading models from the data center to the edge, because energy efficiency is so very important. The fact that transmitting like via Bluetooth or Wi-Fi to maybe your phone or your other devices also causes energy. The more capabilities we could have on the edge, the better. And the more things it could do on the edge on its own would be even better, because like, is it you? Do I need to connect to the phone or the data center to tell that it is you? Probably not. Like familiar faces, familiar things, derive some intent out of that. Like if we could get to that cascade with current and future technology, that would be fantastic.
Yep, we started with energy efficiency. We've ended on energy efficiency. Pretty good. I'm going to ask. I think we're going to finalize now. I'll ask each of you to just give you one thought that you want to leave the audience with on this topic. I'm going to start right at the end, David.
With this topic in general and on Edge AI, well, I think that, so let me do something very tech bro here and pat ourselves on the back. Let me start by that. We started in 2017. That was a very different world. We had big models we were trying to put on CPUs, and then came the first generation of NPUs and optimized models that were designed for the edge. Then came a proliferation of models that were scalable and standardized. I mean, that was those were big strides, that we were able to take advantage of and sort of stand on the shoulders of giants. And now we're looking at sort of the next wave of that, with 2610 now taking transformer models from, where we've seen the benefits of already and are proven in sort of cloud architecture and LLMs, and starting to bring that down to the edge as well. I think that's kind of inspiring a continuous role of AI. It kind of comes back to the question about AI and IoT. I think IoT was just a garbage can for connectivity. Anything that was connectivity was IoT.
Don't worry, you'll get your say.
The difference is that AI is really providing meaningful benefits and new innovative capabilities.
Okay.
And so I think those are the things that inspire change. Those are the things that get people excited. And so I think it's just going to be a rolling continuation.
Billy, your final thought.
So many final thoughts, or beginning thoughts.
Let's round it down to one.
Yeah, I think of it more of a beginning thought than a final thought. I think we're at a point today where we now have the right architecture, the right tools to begin building next level experiences beyond the broken world of IoT and the very early days of AI on the edge. We think of it as edge because we're running things on the edge device, but I think it is a combined, cascaded experience across different nodes and tiers. And so having this set of tools, having these configurable base designs that we can start with, having it in commercial shipping silicon now, what can we all do with that to go beyond the world of the broken IoT that we started with?
Okay, I'm going to move to Pete because Vikram's going to have the last word.
Yeah, so my final thought is Edge AI doesn't have to be the watered down version of Cloud AI. There are things you can do with Edge AI that you just can't do with, practically with Cloud AI. I think we're building a bunch of those things with Synaptics. I'm looking forward to seeing a lot more built, and I'm hoping people kind of really dig into this stuff and see what's possible.
Kai.
I'm actually very excited at where AI is evolving today, right? With kind of like the flip with the large language models and what we could do, and to what we could enable in terms of experiences and capabilities. I work with Billy since, I think, 2016 on various IoT-related projects, leading to now this other endeavor that I'm engaged with. I really want to see how technology could evolve to, I think some of the people talk about like use cases that are very similar to like personalized agents to some extent, right? And these devices and these capabilities would enable that to happen. I think you mentioned offline use cases. Offline use cases is another thing I care very much about. You don't want it to work only when you have connectivity. You want it to work regardless of that, right? You want to work with and without, and it should be seamless. Yeah. So that, anyway, long story short, I'm excited where things are going. I can't wait until where it goes next year.
I was going to add on to that, Kai. I
talk about it right
say
now.
the same thing, basically. We're talking about what's available today and what's launching today with the 2610. We've all been thinking about what's happening in the next 12 to 24 months and actively working on that. I'm hoping that Vikram will allow us to come back in 6 months,
yes,
9
we're
months,
making him nervous
12
now.
months, and we can really impress you with how things have moved in that period of time.
Exactly.
So, final word to Vikram.
Firstly, thank you for moderating this. I actually had a lot of fun on this panel, and thank you to you guys. It's clear, I mean, we are looking at the edge with our own lenses, clearly. But I think we all see the potential in the edge, and we are all very hungry to unlock this potential. At Synaptics, as I mentioned, we are very focused on the core IoT with our sense, process, connect solutions. But a lot of it we're going to overlay with Edge AI. That's going to be our focus. We're going to be relentless in innovating internally and with our partners to try to bring good outcomes and good products. We're going to try to keep simplifying the customer journey, which is another important aspect for AI, I think. Like how do you get models to production, and how do you make it easy, and how do you future-proof it, and all these questions that everybody asked. All of these things we think about on an everyday basis. But we are super excited about where we are. We're on the cusp of a lot of different things. And like Billy just mentioned and Kai alluded to, you're going to hear more from us in the coming months. And we're very excited about the journey we're on.
Well, let's say thank you. I had a great conversation. Thank you to the panelists. Over to you, Nita.
Thank you very much, Nitin. First of all, a big thank you to you for moderating the panel today. Thank you to Kai, Pete, Vikram, Billy, and David for being here and being really, really solid partners. Another round of applause for all of you. Thank you very much to our customers, partners, investors, media for being here.